Welcome to this webinar on Simcenter Amesim, Unifying Engineering Disciplines with Multi-Domain System Simulation. So my name is Mohammed Simak. I'm the application engineer working on electrical, electronics, and systems engineering here at Meson Labs. So as the name suggests, systems engineering, multi-domain systems, right? We know products are moving towards being more futuristic, more modern. Companies are racing against time to innovate the products, right? And so a need of the hour would be a simulation platform which would be able to, simulate multi-domain capability in one platform itself. Traditionally, when we simulate, right, traditional FEA-based simulation, it is domain specific. We focus primarily on the uh, application. We get into detailed modeling of the shape of the component, right? However, here in systems modeling, we're not interested in that. Instead, we try to replicate the physics behind each component by parameterizing the components, and then from there we try to see how the energy transfer occurs between different domains. If I'm changing something in one particular domain, say mechanical domain, how is it affecting something on the thermal side or on the electrical side of things? So these are things that we need to be able to simulate, right? This is where systems engineering, 1D systems modeling comes into picture. So herein, what we do is we basically take components from different domains, 1D, mechanical, electrical, or electronics. You just drag and drop components into your GUI, and then from there, you, yeah, and then from there, we take, we simulate and then we move forward. So this is just a brief, that's just the gist about how system simulation works. And of course, we'll be looking into the same, how we can do the same with Simcenter Amesim. So I'm from Meson Labs, just a brief about us. We are an expert partner for Siemens, one of the leading simulation providers. Uh, okay. And then we will be moving forward now. I'll take you through the webinar. So this is the agenda, what we'll be following for today. The challenges, okay? Current challenges in the industry, also challenges in simulation as well, right? Traditional simulation and why system simulation is needed. A brief introduction to the Simcenter portfolio, and we'll get into what Simcenter Amesim is, how the Amesim core capabilities benefit us in our applications, how organizations have been able to apply, Simcenter Amesim uh, in their use cases, and they've been able to achieve great success due to it. So we'll be looking through a few case studies across different industries in the Unleash Innovations segment. And then we'll be looking at a live demo of the software. And then finally, we will be seeing how Simcenter Amesim, transforms engineering for us in a slide, which will basically cover the core capabilities of the software. And finally, we will conclude with the summary by one of testimonials from one of our esteemed customers, and we will be, concluding with the Q&A as well. So now I'll move forward. Okay. So yeah, when you think about systems engineering, right? When you think about multi-domain system simulation, the number of parameters or the things that you need to keep in mind just to get started, right, are a lot. A lot of questions will come to your mind. Okay. And then like, how do I size all components in my system? How can I connect my virtual system to my virtual sorry, how do I connect my control system to my virtual prototype to validate it before I actually test with the actual hardware? How do I anticipate system integration issues? And how do I optimize energy efficiency, and many more? And these are questions to which we cannot just go forward with say past data or past test data or estimations based on that. or theoretical estimations. Instead, what we need is a platform which will give us the answers to these questions digitally, so that you can move forward with a lot more confidence. Because it is a lot. Even if you were to conduct a test, right, hardware test, and your prototype were to fail at a certain condition, then what would you assign it to the failure reason? One thing could be what directly appears, the direct obvious reason, but there could be many more underlying reasons as well. Okay, so for all of that, we need a proper digital platform to be able to give us these answers before we actually go to the hardware side, prototyping the hardware, I mean. Okay. So simulation today has already proven its worth in the industry. We already know it, right? It's been in the market for decades now. It reduces the need for physical prototypes. It accelerates our development process, and it reduces the costs. So we no longer have to go, stick to the iterative build and break cycles of the past, right? It ensures that we get better products in the market as well. So hence, so for these today's modern, futuristic, innovative products that companies are racing against time to bring out to the market, we need a platform which can simulate these multiple domains. So till now, we've been talking about this from a pure common sense or logic perspective. Okay. But now the same thing has been verified by means of research conducted by European leaders, okay, organizations who focus on this researching the market trends by straight facts. So that what they've done is accurate. Also, what in our particular case, they have conducted a research by carrying out a compilation, or I would say, of different companies, straight from well established organizations to startups. And what they found is that, okay, they compared these organizations by different parameters, such as how well they were able to meet their product date launches, the quality of their products, and uh, return on investment, and such parameters. And they classified these organizations into different rankings, such as best in class, average in the industry, or industry laggards even. So how they so even they say that the best in class organizations today use 1D system simulation to analyze multi-domain behavior. Okay, the 77% best in class integrate multi-physics by doing this. And increased complexity. 44% of systems engineers say that lacking the ability to identify system level issues are major challenges among 44% of system engineers. And 56% of the best in class realize more than 20% reduction in number of prototypes with system simulation. And 55% leading companies use virtual commissioning to verify controller logic before the hardware is ready to be tested. So this is basically what in-depth research has shown us. Whatever we've been thinking from a logic perspective, common sense perspective, the industry trends show the same. That we need, organizations need multi-domain system simulation so that they can stay ahead. Okay. And now we'll get into some of the challenges involved in systems engineering. So as we know that, it just think about it, right? You are integrating multiple physics. So if normally engineers tend to be specialists in one particular domain, and herein you are asking the same engineer to answer the questions such as how a change in his particular domain is going to affect something in a completely different domain. So naturally, it is going to take the engineer some more time to be able to answer these questions. Hence, it involves a good level of complexity, systems engineering in general, I'm talking. Okay. And these organizations today, sorry, organizations today use the Organizations today use in-house tools which enable them to carry out such simulations. However, these tools require quite a bit of learning, you know, to and hence only a certain few people will be able to make the most of these tools. And if, say, for some unfortunate circumstance, such people were to leave the organization, then in that case, these, your systems simulation will be vulnerable because most of these tools is not being made of. A lot is still left because the people who are able to use it have left, and the people who want to use it, the newcomers, even if they try, they will not be able to make the most of such tools. Okay. Now, when the product development process evolves, right, more information becomes available on and more decisions are taken. This means also a high level of detail in models is required. So very often engineers run into limitations of the early models made, where adding more details requires so much rework that making a new model itself is more efficient. So this can repeat itself several times during a single product development process. Okay. So as I was speaking about, system simulation and models are very powerful. So not only to create the right system concept, but also to tune parameters and run simulations for optimization purposes. For example, to meet individual customer requirements. In practice, we hear that both activities are assigned to model experts, right? Because of the complexity and knowledge required to run simulation models. So due to the time restrictions, the result is often that the full potential of system simulation remains untouched. Okay. And well-known system simulation tools typically require a steep learning curve and programming skills before having it usable for engineering. So new engineers who are passionate about implementing their designs come into the field hoping to be able to quickly, build up their designs and validate it. However, if they were to know that they'd have to learn a lot of the tool itself, it would naturally discourage them, and many might not be able to make the most of it, or many might just drop the entire thing as well due to the steep learning curve involved. Hence, this is another challenge that is generally faced in and generally seen in systems engineering. Okay. And integration across existing workflows is hard. Like existing users are already working in workflows which are known to give good ROI, okay, which are known to get the results that the organization wants. And if you were to tell them integrate something completely new, right, into your schedules, and not just meet the current, the output, but better it. Of course, it is going to be challenging and it is going to take some time. So now we have here a customer review from a on user on the independent software review website g2.com. So you can see here he mentions, as an engineer, it is important to me to work on my own product and not to program my own simulation tool. Simcenter Amesim offers me an existing model library with validated physical models with various levels of detail. So it basically tells us how Simcenter Amesim deals with most of the challenges, all the challenges that we've discussed to a great extent. So traditionally in systems engineering, what you'd need to do is you'd need to be able to model the equations behind the components to bring them to life before you can simulate it. So that is another challenge. But however, in SimCenter Amesim, that part is completely removed. You can directly focus on your work by, the capability of the vast library, okay, vast library of industry validated components across domains that is there. So you can just take it and you can just use it in your model, and you can quickly set it up. You need not waste time in the equations part of it or the model rework or the steep learning curve. It is actually very easy. There's not much of a learning curve here. So as I was mentioning, all of these difficult challenges involved in Simcenter Amesim can be quite easily taken care by means of this software Amesim. So just a brief introduction to the Simcenter portfolio of software. So it has software. We have software. Siemens offers software across different domains: structural, fluids, thermals, electromagnetics, chemistry, acoustics, which help us to model the complexity, explore the possibilities, go faster, and stay integrated. So different permutations and combinations you can try out. Okay, detailed insights you can get, and you can increase your the speed of your work, get better output, and stay integrated with your with different teams in the process. Okay, so now coming to what Simcenter Amesim is. It is a systems modeling and simulation platform for every phase of development. Mechatronic system simulation can easily be taken care here. It offers a very powerful platform. System sizing and integration issues can be easily taken care of. Performance balancing for different components can be done, and controls verification and validation can be performed in real time. So as you can see on the screen, how the components are moving by means of the animation. So we have capability to model the 1D system in 3D animation as well. So you get a good view of exactly what you're doing. In this case, the hydraulic excavator arm. You see the different hydraulic jack and the valves moving. Another huge things, even the 1D components, you see it moving, right? So it makes it very interactive for the users to stay focused on their applications. Normally, if all the different components were of the same color, then it would feel very clustered. Every time you try to read or you try to look at a model, you'd need to figure out exactly what component does what. But by taking advantage of the different color codes available in Simcenter Amesim, that can easily be avoided. It helps being focused on the software much easier. You can stay focused. You can, because it's very interactive, and you can get on. So in the other images, you also see a battery thermal simulation being performed, and some aircraft wings as well. So it helps us to virtually assess and optimize the performance of mechatronic systems. Okay. So as I mentioned to you, it has ready-to-use multi-physics libraries and components. System sizing and integration can be taken care of. It is a very open environment. So link in connection with Simulink, FMI, Modelica, real-time target support, and other Simcenter and Teamcenter software is possible. It is a scalable platform. So right from the initial level of your design to your advanced final design, you can do it here. And a lot of exploration and post-processing capabilities are provided as well. And so you needn't start from scratch. A wide range of application and industry-oriented solution models with explanations are available inside the software itself. So you need not, start from scratch. You have good reference. Okay. So yeah, it helps to model the multi-physics system performance by it helps us to predict the complexity with 50 ready-to-use libraries with over 6,500 components, application and industry-oriented solutions. And for advanced controls design, it also has features such as state chart environment and a reduced order model builder as well. So that you can bring in your complex data and the software will convert it into a 1D system model, which you can use as in your simulation. Okay. So now we move to the in unleashing innovation side of the session, wherein we look at Practicon, industrial machinery use case. So they were able to improve the reactor cooling system with Simcenter Amesim. So they created a digital twin of the cooling system and simulated multiple scenarios to verify the new system before implementation. So more than 50 safety critical test case scenarios they were able to virtually verify before the factory acceptance test for their reactors. This cooling system is what they built. Similarly, we, as I mentioned, you can see here the animation of a Formula student vehicle or a Formula vehicle. You can see how the Suspension is reacting with respect to time, the different components involved, including the brake, motor, the driver, and the rest of it, right? So from the early design stages to final performance validation and controls calibration, you can do it here. Linear analysis capabilities, you know that multi-domain system simulation is going to involve a lot of non-linear equations. However, even if in spite of that, to easily be able to do advanced control analysis, FFT, Bode plots, Nyquist plots, to get into all of that, we have the linear analysis capabilities as well. We have a performance analyzer to which gives in-depth details about your simulation. So if a simulation is taking slightly longer than it should, you know what component is causing that and how you can best rectify. Plot, dashboard, as you can see, animation is possible, and design of experiments is possible as well. So just say for each instance, you do not want to make a change and then run the simulation. Just the thought of that, can tell you that it'll take time, right? For every instance, making a slight change and then running the simulation. What if you were able to, uh, you know, run one single simulation, but in the background, the software would solve for multiple values, how the model is behaving across a set of values. So you can do this through design of experiments optimization capability, and you need not take your software to any other what do you say optimization tool. All of this is possible inside the software itself. So Hyundai Motor Group, so they were able to use Simcenter Amesim to analyze hundreds of parameters to optimize their chassis performance. So they were able to achieve 99% reduction in subsystem parameter optimization process time. So from 1 week when they were manually changing the values to 15 minutes when they made use of these optimization capabilities for their chassis. Okay. And it has a lot of integrated design exploration tools. You can create your own custom widgets for different purposes like importing model parameters, automatically running simulations, or launching post-processing scripts. And workflow customization is possible as well. So there is a lot that you can do. So your own custom widgets, okay, are called as apps in the software. So you can build them and you can customize the software for yourself as well. You need not follow the same standard procedure which everyone else follows. So as your expertise in the software grows, you can do a lot. You can explore a lot. So in the renewable energy segment, Plastic Omnium, they developed fuel cell systems with Simcenter Amesim. So they were by using Simcenter Amesim and reduced order model simulation, they were able to cut development time by 25%. So Cummins, so an organization that has been in the market for more than 100 years now. Okay, so they specialize in this engines for heavy equipment industry, and they've used Simcenter Amesim to cut down the number of prototypes by 50% and reduce lead times by 1 month here. So as mentioned again, it has a pretty open environment, so you can link and connect with Simulink, FMI, Modelica, real-time target support, and other Simcenter and Teamcenter software. CAD import and embedded CFD capabilities are also there. An initial level of CFD analysis, you can do it inside the software itself. It uses a little bit of star CCM in the background. Okay, CAD import to just take some data into your components easily. And of course, with Simulink and other software as well, you can easily link. And it also has a direct co-simulation with star CCM for your if you want to do some advanced CFD analysis parallelly with the rest of the components of your system, you can do that as well. So Audi, they use Simcenter in a semi-automated workflow to generate 1D models from 3D CFD while increasing the correlation between the simulation data. So what they could achieve in Amesim was less than 1 minute simulation time for the charging scenario instead of a day in what would take in a dedicated CFD solver. So they're able to enhance the accuracy and the speed of the simulations as well. So this is the live demo part of the software. Okay, this is what I wanted to try to model. I wanted to show you how you can quickly set this up, an initial level model, and use so that you see how the different domains can quickly interact with each other, and you can easily solve. So ailerons are basically um, the small flaps at the end of the aircraft wings. Okay, so they actuate, they turn on when the aeroplane has to flip or tilt in one particular direction. So I have a short video which explains just that. I'll just play it. So this is how ailerons work basically. So on an initial level in the software, right? We want to model it with these components: a voltage source, a converter along with its motor, a gear to be able to reduce the speed while increasing the torque, and a transformer, which is nothing but an ideal lead screw, which can convert the rotary motion into linear motion, which you can use to actuate the aileron. Okay, and a flight control module to be able to give the commands as well when it has to, actuate, and when the aileron has to hold. So we will get into the software right now. I have a video for the same. Just a second, I think it's loading. Yeah, so you can see here, right, how the here we have a motor and we have a few power sensors, we have a voltage source. For the flight control module, we've modeled it by means of PID loops for the speed loop and the position loop. We have a speed sensor. Okay, we have the gear component. We have the transformer, the lead screw, and finally we have a few sensors, and we have a lever arm to act as the aileron. And to add the aerodynamic load, we have the stock source and the load here. So here in what we are going to do is basically we're going to run the simulation. We're going to see how easily the soft, and of course we have the gravity component and the run stats component as well. So initially you set up this model in the sketch section, wherein you drag and drop components from the library browser, and then you make the wirings, and then you go to the submodel section, wherein you can fine tune each component. Whether you want to increase the fidelity, or you want to keep it to a minimal level, or you want to slightly change the type, you can do that as well. And then you go to the parameters section, wherein you enter the parameters of each component to define the physics. And then finally, you go to simulation, wherein the software itself will do all the compiling for you. You need not do anything to, how do I say it, set up the simulation per se, this or the solver per se. The Amesim solver will take care of all of that, right? So we just need to simulate it, and then we will get the output. So what we're trying to do is we're trying to actuate the aileron at a time of zero point 0.5 seconds, and we are going to see how the output waveforms respond, whether the motor is able to handle the load, and so on. And at a time of 2 seconds, we're going to apply the aerodynamic load or the wind acting on the aileron to see if it's able to hold. So we're in the simulation section now. Okay. And so yeah, the simulation has quickly been completed. So these are the output waveforms that you can see for the actuator and the motor. Okay, the motor speed, the motor torque, the input current. So you can see here, right? At that instance where the aileron is turned on, we see a spike in the values. And similarly, at the time frame of 2 seconds, when the aileron is subjected to the aerodynamic load, we see the small spike. So we know that our system is able to hold it. Yeah, and you can see the actuator position, the the reference that we are giving and how it's meeting that position, and the force and the aileron angular position as well. So you can see the slight changes at the once the aerodynamic load is applied, and the slightly bigger change once the actuator is turned on. So similarly, we can see the same for the uh, power as well: mechanical rotational power, mechanical linear power, or motor input power. Okay. So this is the demo that I wanted to take you through. Okay. Is So these are some of the libraries. These are all the libraries actually. I just give you an idea of the different things that you can simulate and do in Amesim. So we have aerospace and marine, right? Air conditioning, aircraft electrics, aircraft fuel system, automotive electrics, cams and followers, CFD gas dynamics, cooling systems, electric motors and drives, electric storage, electrical basics, static conversion, electrochemistry, gas turbine, okay, heat exchangers, liquid propulsions, 1D mechanical, 2D mechanical, 3D mechanical. And we have the engine signal generator, the filling, the fluid storage, the fuel cell components, the fuel cells and electrolytes, gas. So all of these will have its own set of components. Okay. The library browser will contain each unique components to for each of these libraries in their own unique color codes. Components to design the powertrain for advanced control and signal modeling, thermal hydraulic, two-phase flow, and vehicle dynamics as well. So just to give you an example, or just to show you how the applications examples look inside the software, I've just put this slide here. Of in the aeronautical section, you can see the different applications that are possible, right? Right from flight controls to flight dynamics, environmental control systems, fuel systems, cryogenic systems, electrical systems, landing gear, propulsion systems, hydraulic systems, engine equipment, integrated systems, unmanned autonomous systems, and so on. So, under each of these, inside each of these, we will find a set of applications, the models that are already there, that are already built, which you can use to get started, use as a reference for your design. So this we have it across industries. I just put example of the aeronautical section here just to show you. Okay, so this is the slide to summarize the different capabilities of Simcenter Amesim. So it offers a powerful open platform with a wealth of ready-to-use libraries, customized apps, integrated design exploration tools, advanced linear analysis capabilities, sophisticated performance analysis features, and seamless integration with the other Siemens solutions and third-party tools as well. Okay, so all of these will empower engineers to optimize complex system designs and streamline their engineering workflows, deliver innovative, high-performing products that meet the evolving needs of the customers of different organizations. So right from complex to be able to model complex systems easily by means of 50 ready-to-use libraries, okay, with more than 6,500 components, to application industry-oriented solutions, and for your advanced controls, a state chart environment, reduced order model builder as well. And it's a scalable platform, like I mentioned, from the early design stage to the final performance validation and control calibration, linear analysis capabilities, performance analyzer, plot, dashboard, design of experiments. And to go faster, right? It has, as I mentioned, the software has powerful platform capabilities, integrated design exploration tools, customized apps to import model parameters, automatically run simulations or launch post-processing scripts, and workflow customization as well. Okay, and then yeah, to stay integrated in the in an open environment is provided. link and connection with Simulink is there. FMI, Modelica, real-time target support, other Simcenter solutions, and the Team Center software. CAD import and embedded CFD capabilities are there, and you can easily do co-simulation with a lot of different software. Okay. And now to to summarize, we can make use of these testimonial from our esteemed customer from B Medical Systems, who's the head of cooling technology and testing. So engineering time needs to be optimized to create the best designs in the shortest time. The accuracy and ease of use of Simcenter Amesim plays a big role in making this possible. So as I was mentioning, these different organizations have been able to make the most of this software for their applications. And this B Medical in particular, they were able to adopt Amesim at a time when vaccine cooling devices for transportation and storage needed to be developed and delivered urgently. Okay, so around that time is when they adopted the software. So by getting parameters from suppliers, they could easily and quickly try out components with short lead times in Simcenter Amesim to see if they did improve performance of the system. So now, by the time that they are ready to build an actual physical prototype, it's much closer to the optimum design, saving a significant amount of time for them. Okay. So yeah, this is the content that I wanted to cover as a part of this webinar.